Algebra Unit 6, Lesson 3, Solving Systems of Equations by Elimination, Day 2, Notes and Video 5. Sometimes you may have to change the coefficients to be the same, or again to be the opposite, by multiplying or dividing the entire equation by a factor. Okay, so this lesson and video is about still solving two linear lines, two linear functions, two equations for where the point in which those two lines intersect or cross or meet. By elimination, we can't graph and we can't substitute. Elimination means we have to add or subtract these two equations together in order to eliminate or get rid of one of the two variables. Again, it doesn't matter which one you choose to get rid of as long as you're eliminating one, either x or y. This lesson is a little bit harder because we can't just look at the two equations and say, okay, 2 and 3 are the same or opposite, so we'll add or subtract them. Negative 3 and negative 2 are the same or opposite, so we'll just subtract them. Instead, we have to modify one of them or both of them so that their coefficients become the same or opposite. We're going to start with letter B, then do A together. Okay, when solving by elimination, we're first going to look at the coefficients of the matching variables. So I have x, 4x, 2x. They are not the same, nor are they opposites. Then I'm going to move on to y. 3y, negative 7y. They're not the same. They're also not opposites. So I cannot solve by elimination like we did yesterday or day 1 or video 4 because I can't simply just add or subtract these two equations. So then I need to modify in some way one or both of those equations to make the coefficients be the same or opposite. So I'm going to again look, before I jump in and do the problem, I'm going to look carefully at the coefficients and say, can I easily manipulate one of them or both to eliminate the other? So again, starting with x, 4 and 2. Well, if I have the 2, if I multiply the second equation by 2, I would make x become 4. Then both equations would have 4 x's, so I could subtract them and eliminate them. So my best bet for letter B is to multiply the second equation by 2. So I'm going to rewrite the two equations. 4x plus 3y equals 32. And I'm going to distribute the 2 to every single term in the second equation. 2 times 2 is 4x. 2 times negative 7 is negative 14y. 2 times negative 18 is negative 36. And now I solve by elimination. To make it so we can read that, I either add or subtract these. So I have 4x and 4x. The only way to eliminate or get rid of those would be to subtract. So 4x minus 4x is 0x, or 0. They cancel. I'm not even going to write that 0. And now I'm going to go every time. 3y minus negative 14y. If you have it memorized, we double negative means we add, or just type it in the calculator. 3 minus negative 14. Get a positive 17y. 32 minus negative 36 becomes 32 plus 36, which gives us 68. We divide both sides by 17. We'll get y equals 4. And again, we're partially done the problem. So of the ordered pair, we have the y. We need to find the x. Okay, so B. I now know y. I need to go back to the original equations, nothing that I modified, and pick which one looks easier to me. It doesn't really matter, so just pick which one you like more. I'm just going to pick the first one. 4x plus 3y equals 32. Now I believe that y is 4, so instead of y, I'm going to plug in what I think it is, which is 4. And then I'm going to solve this 7th grade math problem. 3 times 4 is 12. Now I'm going to drop the wall and solve. X is being multiplied and added. In order to undo that, I must do SADMAP, or the order of operations in reverse. So I'm going to subtract 12 from both sides. I get 4x equals 20. Divide both sides by 4. I get x equals 5. So now I'm going to bring my answers together. Remember, beginning of the chapter of this unit, we had two lines where they intersect was the answer. So 5, 4 is the ordered pair in which these two equations intersect. All right, let's go back and do letter A. Again, before we start, just look at the problem and observe what's happening. I have 2x and 3x. They're not the same, they're not opposites. -3, -2, not the same, not opposites. There is no way that I could easily change 2x into 3x. There's no way that I can change -3y into -2y. Now, some of you are like, hey, we can multiply by fractions and decimals. It's true, you totally can. But I still have a lot of students that are, I'll say, fearful of fractions and decimals. So let's try to avoid those, look for whole numbers. So we almost want to look for the least common multiples, way back from 6th grade. 3 and 2, what is the least common multiple? And again, it doesn't matter if you get rid of x or y first. I'm going to choose to get rid of x's first because they're positive and that sounds easier for me. So the top equation, I need to multiply by one thing, and the bottom equation, I need to multiply by something else. So how do I change 2 into 3 and 3 into 2? I can't. So what's the least common multiple? So way back in 6th grade, we would have written 2 and 3. We would have listed the multiples. 2, 4, 6, 3, 6. Least common multiple is 6. So I need a way to change 2x into 6 and 3x into 6. Top equation, I'm going to multiply by 3. Bottom equation, I'm going to multiply by 2. Again, I'm going to distribute that to each piece or each term and almost make two new equations. Now, if we're solving by elimination, our goal is to add or subtract these together so that we eliminate a variable. If they both have 6 x's, if they're both the same, that means I'm going to subtract them. 6x minus 6x gives me 0, which is what we wanted in an elimination problem. -9 minus -4 is really -9 plus 4, which gives us -5y. 30 minus 30 is 0, which means y is 0. Again, we're partially through the problem. We now need to find x. Now, again, we have to go back to the very beginning. Not the manipulations we did, but the very beginning. Pick which one you think is easier. Again, any problem that you want, or any equation that you want. 2x minus 3y equals 10, I'm going to choose. And instead of y, I'm going to plug in my 0, which I think y is. Continue and solve. I should get 2x equals 10, which gives me x equals 5. So my answer then is 5, 0, the ordered pair. All right, I would like you to pause the video, try C and D on the front. When you're ready to check, I'll write the answers for C and D on here. But again, take time, pause, and show all of your work. If you run out of room, like I ran out of room, grab some tablet, some extra notebook paper, and write that down too. On the back, the next 6 problems are all about the same difficulty level. You're trying to eliminate one of the variables. The only way to do that is to add or subtract the two equations together. Sometimes, again, the coefficients are not the same, or they're not opposites. Therefore, you have to really look at the two equations, examine them, decide which variable would be easier. Again, do what's easier, whichever variable would be easier to get rid of or eliminate, and choose to multiply that equation or both equations by a number to do that. I'm going to move and do letter F for you, as that's our first one with some fractions. So I see half x, 1x, 2y, 1/3 y. If I multiply this entire first equation by 2, I'll get rid of that fraction. So that's what I'm going to choose to do. X plus 4y equals 54. The second equation, x plus 1/3 y equals 10. So now our x's are the same, so we're going to subtract. X minus X cancels, so we're left with Y. 4Y minus 1/3 is 3 2/3 Y. And again, as I write that, I'm like, oh, mixed number. Let's make it improper right now. So 3 times 3 is 9 plus 2 is 11/3 Y. Equals 54 minus 10 is 44. I'm going to multiply by the reciprocal, 3/11. And I'm left with y equals 12. Now that I know y, I can pick either equation from the beginning and solve for x. I think the second equation is easier, so I'm going to plug y in for 12 there. So x plus 1/3 times 12 equals 10. I get x plus 4 equals 10, which gives me x equals 6. And now let's do Our final answer then is the ordered pair 6, 12. And we're finished. Okay, please take a minute and pause the video. I want you to finish those last 5 problems. Again, before you jump into the problem, try to only multiply or divide one of the equations if you can. Again, the more work you do, the more likely you are to make a mistake. Okay, go ahead and pause the video. When you press play again, I'll have the ordered pairs or the solutions to each of the last 5 on so you can check them. If your answers do not match, don't panic, but start fresh. Look over everything you did. Maybe you mismultiplied or misadded. Could be a teeny tiny mistake. Good luck. Okay, check your answers for E, G, H, I, and J.